All right, good morning, everybody. Let's talk about the liver. Okay, there were two other functions of the liver that we talked about yesterday. The first is the detoxification side of it. Let's try spelling that again. Detoxification. So remember that there's two sources of blood into the liver. So here's our liver. We have the hepatic portal vein and we have the hepatic artery. And it's the hepatic portal vein that brings substances right from the digestive system. And that your liver does its best to try to get rid of all that stuff that doesn't belong, like right away. Now, that's the detoxification side of it, okay? So detoxification, this can wear down over time if you subject your body to lots and lots and lots of these substances. I believe I told you the story about the person I knew who let me know why they were on the liver list, and I was super shocked. So here's the deal. A lot of these substances, many of these toxins are what are called fat soluble, which means they don't dissolve in water, but they can easily dissolve into your cell membranes or into your fat tissues. And normally people that are overweight stay overweight. And so that means you could get a toxic buildup of these substances inside of your fat tissues. Remember that word adipose? So because these things are fat soluble, but when we urinate, when we defecate, there's water associated with that. It means that these things are difficult for the body to excrete. So that's a real problem. And so what the liver does, let's try that again. It should be excrete. All right. So what the liver does is it breaks these down into more harmless substances. And it makes them water soluble so that they can be transported through your blood and be gotten rid of in the normal ways. Let's see about a good picture for this one. Let's find our picture here. Here we go. Let's try this again. There we are. All right. So, you ingest the toxins, they get into your body. Now, what are some examples of some fat-soluble toxins? Well, there's mercury. Anytime you've had any kind of big fish, like a swordfish or a tuna fish or something like that, there's a good chance you've ingested some mercury. Mercury is released when we burn coal. Right now, our government is trying to ease restrictions on how much mercury can be in coal smoke, which is really problematic. Because that coal smoke goes up into the air, comes down in the rain, and then gets into our food supply. You ever heard of PCBs? These are molecules that are found inside of plastic waste. We get a lot of those inside of us too. Some kind of molecule called a dioxin, which is in a very commonly used bleach. All of these are things that get into our bodies pretty regularly. All right. So the first thing that happens is these molecules need to be changed into less harmful molecules. This can be done through a bunch of different kinds of reactions, like oxidation reactions. These oxidation reactions can, add oxygen to something. The opposite of an oxidation reaction is a reduction reaction, where instead of removing electrons or adding oxygen to something, you do the opposite of that. And we also learned about hydrolysis reactions. Remember, hydrolysis reactions is when you add an H and an OH to something to break it apart. It's the opposite of a condensation reaction. Okay. Now, a lot of times, these reactions can produce what's called a free radical. A free radical is an unpaired electron. Remember that electrons like to be in pairs. And these unpaired electrons are really dangerous. They're really reactive, which is why they're called radicals. And so your liver produces antioxidants, which attach to these unpaired electrons to make it not so reactive. They get neutralized. So now you've got this intermediate. So this is another molecule right here. The intermediate is the molecule in between the dangerous thing and the not dangerous thing. So it's not quite there yet. So now what has to happen is it has to be conjugated or added to something else. It's going to get added to another molecule. And this makes it even less harmful. And it makes it water soluble. All right. Now that it's water soluble, it can travel through your blood and get to the right places by either getting down to your bowel or your kidney and coming out in your feces or urine. And you are now less toxic. You might still be toxic, but, not in the molecule kind of way. All right. The other thing that happens, and if you take a look at the notes again from yesterday, is that your liver recycles your erythrocytes. You might say, well, you didn't say that yesterday. You said it recycles red blood cells. That's because erythrocytes are red blood cells. Cyte means cell, and erythro refers to the red color. So your red blood cells only live for about 120 days before they get recycled. They barely have anything. No nucleus, barely any organelles. They just carry hemoglobin, and so they have to be constantly regenerated. And so the liver is responsible for breaking these down and recycling all of the components. These components are either used to make more red blood cells or to make other important things. For example, one of the things the liver makes that is made of old red blood cell parts is bile. Remember bile? Okay. This erythrocyte recycling happens in the liver in a kind of cell called a Kupffer cell. This is a special kind of cell called a phagocyte. Now, we've talked about phagocytes before, but a phagocyte does this engulfing thing where, it's best if with a picture. Let me go find a picture. And I'm back. All right. So the phagocyte is a kind of cell that engulfs. Hello, use this one. Yes, here we go. Okay. It's a kind of cell. It's a white blood cell. It can be a white blood cell. It doesn't have to be a white blood cell. But a phagocyte, one kind of phagocyte is a white blood cell. And it can engulf or surround something, close it off, and now it's in this little thing where it can be broken down or digested. That's what a phagocyte is. And a Kupffer cell is a very special kind of phagocyte. All right, so what is in your blood? Well, there's three things that we need, there's really just like a couple things we need to remember about what is in a red blood cell. A red blood cell has a membrane, and it has a bunch of hemoglobin in it. Now, hemoglobin is made of a couple of different things. The globin part of it is the protein, And remember that proteins are made of amino acids. And the heme part of it refers to iron atoms. Your hemoglobin molecules have iron atoms in them, and it's those iron atoms that hold on to the oxygen. Okay, so the first thing that happens when a Kupffer cell breaks down is that the hemoglobin gets broken down into its globin and its iron heme groups. This globin gets broken down into amino acids using a protein called a peptidase. We've been talking about these kind of words all year. You should be able to break this one down. The ACE means that it's an enzyme, and peptid means that it breaks the peptide bonds down in a protein. Okay. And your liver sometimes will recycle these amino acids, because remember that your liver makes a bunch of proteins, and so it might use these amino acids right away. Or remember that amino acids can't be stored in your body, and so these need to be broken down or metabolized so that you can get rid of them. And if you remember yesterday, remember that amino acids will get turned into urea for you to get rid of. All right. The iron heme group isn't just iron. There's a little bit of another molecule there. And so this iron heme group will get broken down into its iron. And the other part of it is something called bilirubin. Okay. Bilirubin. Now, this iron can be stored in the liver. Can be. But the iron itself is a little bit reactive, and so it has to be stored in a protein shell to protect it from reacting. And this protein shell is called ferritin. Ferritin. This name should be easy to break down. The in means that it ends that it's a protein, and ferra refers to iron. And remember, the symbol for iron is Fe. That should be easy to remember. Or it doesn't have to be stored in the liver. There's a big or here. Or this can be sent to the bone marrow to make new hemoglobin. To make new hemoglobin, because that's where your red blood cells are made. Your red blood cells need hemoglobin. Okay, to make new hemoglobin. Once again, it needs a protein to do this. And the protein that is used to help transport the hemoglobin to the bone marrow is transferrin. This is nice. It's a protein, so it ends in. It's transporting, so it's trans, and it's transporting iron, so it's transferrin. So clever, isn't it? All right. Now, this bilirubin, let's come back up to this bilirubin here. This bilirubin can be used in bile. And so the bile that your liver uses in order to help your digestive system break down those fat molecules into smaller pieces that can be digested. That bile contains bilirubin that came from red blood cells being recycled and broken down inside of your liver. That's interesting. Now, sometimes if your liver is having some trouble, if your liver breaks down too many red blood cells, if you have some transport problems and some of this bilirubin leaks out into the surrounding tissue. So this is a problem that could happen. Bilirubin leaks out. And if that bilirubin gets into your blood, bilirubin is a pigment. It is colored. And it can actually cause your skin and your eyes to become kind of yellowish. And this is an indicator of some liver disease, and this is a problem called jaundice. And you might be familiar with somebody with jaundice, but I've got some pictures here to show you what this jaundice looks like. Here's an example of the yellowish eyes of a person with jaundice. The white part of the eye is called the sclera, and this sclera can become yellowish because of a buildup of bilirubin. This person's skin doesn't look particularly yellow. I found this pretty interesting picture of a patient with pretty severe jaundice. I mean, that's really yellow. Pretty common in old people. They've lived a whole life of putting things into their bodies, and the liver can sort of get tired. But also, about 3 in 5 babies comes out jaundiced. Whoops, wrong button. Okay. About 3 in 5 babies comes out jaundiced, so 65% of babies, or about 60% of babies. It's normally not a real problem. In fact, my son, George, came out jaundiced. Sometimes it takes a few days for the baby's liver to kick in. If the baby isn't breastfeeding very well, then they can become jaundiced, and it's pretty easy to fix. Jaundice can be broken down just by some UV light, and so my son was given this little blanket that had lights built into it, and you just sort of put it on him for an hour a day, and after a couple of days, pow, no jaundice, and he's fine. I mean, he's crazy, but he's fine. So how does this work? So there's all kinds of things that can cause jaundice. Let's go over here. All kinds of things that can cause jaundice. There could be some kind of liver disease that challenges the removal of bilirubin in the liver. The gallbladder is where the bile accumulates. And so if you get a blockage in the gallbladder, it could prevent the secretion of bile, so the bile can't secrete, which causes a backup and it can spill out into surrounding tissues. Or you could have some kind of anemia, which is damage to your red blood cells inside of your blood, and so that bilirubin is spilling out inside of your blood vessels rather than actually being broken down in your liver. All right, that's it for the liver. Tomorrow we start the immune system. All right, take it easy.